welcome back to the channel again. Today we will discuss more functions of standard template library. Till previous video we have discussed the accumulate function. Now we will discuss the binary search, lower bound, upper bound and many more functions of standard template library. Now first of all we will look at binary search. Now for binary search, one necessary condition is that our array should be sorted. So for using binary search, first of all we have to sort it. So how we will sort? Using simple array plus n. So after this our array will be sorted. Now for binary search, we just want to make these changes. Now here binary underscore search. Binary search, here we have to pass the starting argument, last argument and the value which we want to search. Now suppose I want to search 12. Now I will get answer as 1. We got 1. So 1 means we found that value in this array. Now if we search for something which is not in array, 1 3 2 1 3, so it is not in the array. Now if we run, we should get our answer equals to 0, and we get our answer equals to 0. So binary search, what it do, it just search that your element is there in your this whole array or not. If it is there, then it will return true or 1. If it is not there, then it will return 0. So this is the binary search for you. Now we will go for the upper bound and lower bound. Now if you don't know what is upper bound and lower bound, first of all I'll explain you what is upper bound. So for this also your array should be sorted. So for that I'll do 1 3 4 5 6 like this. Now suppose I want to find the upper bound. So for upper bound, this, suppose we want to find the upper bound till 4, so this will return 5. So it is just returning the number which is just greater than the number which you are finding. Suppose you are checking the upper bound of 4, so it will return 5. If you are checking the upper bound for 3, it will return 4. Similarly, the lower bound is just the opposite case, just smaller it returns 4. If you want to find the lower bound of 4, it should return 3. If you are finding for 3, it should return 2. So this is how we have to find the upper bound and lower bound, or this is how we have calculated the upper bound and lower bound. Now we does not require to sort because already we have given the sorted array only. Now for upper bound, we want to just write upper underscore bound. Now in this also starting element, last element and the value which you want to find out. Suppose 3. Now what we will get as answer? So we have got an error. Why? Because it returns a integer, a pointer which will point the index. So in this case we will get our pointer and we have to print that pointer. Now we are finding the upper bound of 3, so our answer should be 4, and our answer is also coming 4. So upper bound is just doing simply this thing. Now if repeated values are there, suppose 3 3 values are there, then also the answer will be 4 only, because it is just finding the just greater number than this, so 4. Now if we want to find the lower bound, just replace the upper bound by lower underscore bound. So same we are trying to do for 3 only, so answer should be 2. Our answer is 3. Why? Because in lower bound 3 also takes, means if we are trying to find for 3, so 3 also will be taken in the lower bound. So we just try to find out the lower bound for this question. Now we have discussed the binary search, lower bound and upper bound, but for all these 3 things, one thing which you have to keep in mind is that your array should be sorted. If your arrays are not sorted, then you will get some error or you will not get the proper answer. Now the next thing which we are discussing is swap. So swap is also an inbuilt function in STL. We just, if we want to swap 2 values, so we just directly pass the values. Suppose I want to swap the arrays 0th index and arrays first index. Now first of all I'll print them both. After this I'll use a swap, and in this I'll pass two arguments, which is array1 and array2. So I'll pass it, and again I'll print it. So I'm just copying it. So answer should be what? First of all 1 and 2 should be there, then 2 and 1 should be there after swapping. So we got our answer, first of all 1 and 2 and then 2 and 1. So this is the swapping function. So it is not any complex thing, that's why I have explained it in brief. Now we'll discuss some of the math operations like power, log, tan and that all. So first of all we'll find the power. So for that I'll take first two values as an input, so it does not require these all things. I have not initialized k, so first of all initialization of k. Answer we don't require, and we directly return power. So power, in power first value should be the base, whichever base it is. So in this we are finding the base equals to 9 and the second value is the power of that. So in this case 6 to the power 1 is the value. Now suppose I want some more things. I given 6 and 2. So answer should be 36 in this case. So if I run the code, so I find the answer equals to 36. So this is the power operation. Now I want to find the minimum value of these both. Simply I can write the min and control B. So the answer is 2, which is the minimum value. Similarly we can find the maximum value also, max. So this will find us a max. So answer should be 6, and we got 6. So we have find the max. Now if suppose I want to find the square root or the root of n digit, so for that also we have a function which is sqrt. So for square root we have given this value, so n, and we got our answer equals to 2.44949, which is the square root of 6. Now suppose type it here 9, so our answer should be 3. So what we are getting? We are getting 3 as an answer. So we have a square root function also there in this STL functions. Now let's do one more thing, which is absolute, ABS. Now what this do? It just removes the sign of the thing which we are doing inside. Now n is 9 and k is 2. So k minus n, what the value should be? Minus 7. Now if we use this ABS function, what we will get? Let's see. So we are getting 7. So it is just ignoring the minus sign. So we have discussed 5 math operations, which are max, min, power, square root and absolute. So these 5 math operations are also important for this STL series. Now in this there are many more functions also, like log, tan, sine, cosine, that all are also there in this. So you can refer the link in the description for more such functions. For comparative, this much which I have told is enough for you. It does not require more. Suppose someone's mind some is coming that how to find the sum of 2 digits, or somewhat how to find the sum of n digits. So for that I have told you a function which is accumulate, which we have discussed in previous video. So for that you can check my previous video also. So in this we have discussed first the binary search, then upper bound, then lower bound. After that we have discussed some of the math operations. Now I have left some of the STL operations which especially works with some of the data types, like some of the operations work with the vector only, and some of the operations work with set only, and some of the functions are there which only work with map or undimensional map, and many things are there. So for that, whenever I'll teach the data type, and in that we will cover that all functions. So in the next video we will cover the vector or the vector functions and all about the vector. So for that you can subscribe my channel, and don't forget to share my video, and do not forget to like also.